This video is to review section 6.1 and 6.2 and prepare you for your Module 6 knowledge check on section 6.1 through 6.2. So in number 1 it says, can these numbers be the length of the sides of the triangle? So to show your work, you want to use the triangle inequality theorem. So the triangle inequality theorem says that if you have the small side plus the medium side, that sum has to be greater than the large side. So if you have lengths 1, 2, and 3, 1 would be the small length. So you'd have 1 plus the medium length would be 2. Okay, so 1 plus 2, and that has to be greater than 3, which is, in this case, your large side or largest length. So 1 plus 2 is 3. Since 3 is not greater than 3, it's equal to 3, then this would not form a triangle. Okay, so the sum of the small and the medium side has to be strictly greater than the large side, otherwise it's not going to form a triangle. Okay, so make sure you have that triangle inequality clear. The small plus the medium has to be greater than the largest side. Okay, so in number 2, it says that the lengths of two sides of a triangle are 29 and 30. What would be the largest possible whole number that the third side could be? So again, you want to use the triangle inequality theorem that says that the small plus the medium side has to be greater than the large side. So since you're trying to find the largest side, what I'm going to do is I'm going to let x equal the large side. Okay, then when I plug the values into my inequality theorem, the small side would be 29, the medium side would be 30. So the sum of 29 plus 30 has to be greater than the largest side, which is x. So I add 29 plus 30, and I get 59. So 59 is greater than x. That means x has to be less than 59. So the largest that value could be would be 58. Okay, so 58 centimeters is the length of the largest side. Okay, now keep in mind that on the actual knowledge check, you're just going to write the answer. You're not going to need to write full sentences. And then some of the problems will also be multiple choice. So for your practice quiz or review, you can write out the sentences as shown in class in your notes, but on the actual knowledge check, just write it. You would just write 58 centimeters. Okay, in number 3, it says that a triangle has two sides that are 8 centimeters and 13 centimeters. What could be the length of the triangle's third side? Select 3 that apply. So it's going to be very important that you read the instructions. So there's going to be 3 answers. So if you don't have all 3, this problem would get marked completely wrong. So make sure you select all 3 of them. So there are different approaches to do this problem. I'm going to show you the way I would do it. So if you have the triangle inequality, again, you take the small plus the medium side has to be greater than the largest side. So one way to look at this is to look for how small and how large your triangle, your third side could be. So what I'm going to do is first I'm going to look for how the largest that my triangle length could be, and then I'll look for the smallest that it could be. So if 8 and 13 are my sides, that means I could let 8 be the small side, then 13 be the medium side, then I'm going to let x be the large side. So 8 plus 13, that would be 21. So if 21 is greater than x, that means x is less than 21. Okay. Then I would look for how small, what's the smallest that my third side could be. So in this case, I would have to let the small side be my variable, so I'm going to call it y. So y plus my medium side would have to be 8 this time, and my largest number is 13, so 13 would be my largest number. Okay, so I would solve for y, so I would add -8 to both sides. So I would get that y is greater than 5. So that means that my sides could vary between greater than 5 or less than 21. So now when I select my answer choices, if you look at A, it says that it could be 5 centimeters. Well, according to my answer, y has to be greater than 5, or the third side has to be greater than 5, so A wouldn't work. So let's look at B. B says 10 centimeters. 10 centimeters is greater than 5. Now I have to make sure it's also less than 21. So 10 is greater than 5 and also less than 21. So that means that 10 centimeters would work. Now let's look at 17 centimeters. 17 centimeters is greater than 5. It's also less than 21. So C would work. D says 20 centimeters. Well, 20 centimeters is less than 21 and it is greater than 5. So D would work. E, 21 centimeters. 21 centimeters is not less than 21. It's equal to 21, so it can't work. So E wouldn't work. And then F is 24 centimeters. So 24 is larger than 21, and my sides can only be greater than 5 and less than 21, so that doesn't fit the boundaries. So that means only B, C, and D would work for number 3. Okay, number 4 says to determine how many triangles can be made given the following conditions. So if you have a triangle that has 2 angle measurements and the key word is the included side of 13 feet, so this forms one unique triangle. So you learn this in lesson 6.1b. Anytime the key word is included, if you have an included side or an included angle, then you're going to get one unique triangle. Okay. If you have a triangle with angles 43 degrees, 46 degrees, and 91 degrees, when you have 3 angle measurements, you're going to have infinite amount of triangles. So if you're just given angle measurements, then you can create an infinite amount of triangles. But first, you also need to check that these angles actually add up to 180 degrees. So I would add up 43 plus 46 plus 91 to verify. So the sum is 180 degrees. So that means that you would have infinite or more than one triangle. Okay, so you can say infinite number of triangles or more than one triangle. Either answer would work. Okay. So number 5, you want to have a triangle that has two angles with measures 60 degrees and 75 degrees with an included side measuring 20 centimeters. So you're looking at two angles and a side between the two angles that measures 20 centimeters. So if we look at A, you have your 20-degree angle and your 60-degree angle, but the side is labeled at 75. So that's completely wrong because the side has to measure 20 centimeters. So A wouldn't work. B, you have two angles 60 degrees and 75 degrees, and then you have your side in between the two angles. So that means the side is included between the two angles, and that side measures 20 centimeters. So B works. C, you have two angles, but your side is not included between the two angles. So that means that C wouldn't work because you're looking for the included side being between the two angles. D, all of the sides are labeled. So instead of the angles being measured and one side being labeled, all of the sides are measured as 75, 60, and 20. So that wouldn't work because this is completely wrong. Okay, so the only one that works would be B. Number 6, if you drew a triangle with these measurements, which kind of triangle would it be? So the angles are 40, 50, and 90. As soon as you see a 90-degree angle, that indicates that it's a right triangle. So the 90-degree angle would tell us it's a right triangle. And then you have four sides that are 4, 7, and 8. All of these side lengths are different. So they have different lengths. So if the sides are different lengths, that would be a scalene triangle. So now we want to look at our choices. We want to look for right scalene triangle. So that would be letter B. Okay. Number 7 through 8. It says, what is the scale factor from triangle ABC to triangle DEF? So basically the scale factor is what you multiply the side lengths of triangle ABC by to get the side lengths of triangle DEF. So if we're looking at, pick one of the sides, one of the corresponding sides. So if I look at side AC, AC corresponds to side DF, which is 54 units. Okay. So the scale factor is what do I multiply 9 by to get 54? So you can call your scale factor x. So you could say 9 times my scale factor, which is x, has to equal 54. So if 9x equals 54, divide both sides by 9. So 54 divided by 9 is 6. Okay, so that means the scale factor is 6, and that's because 9 times 6 is 54. Okay, number 8 is asking you for the scale factor from DEF to ABC. So we're going from the large triangle ABC, or sorry, DEF to the smaller triangle ABC. So you can look at any two corresponding side lengths. So I'm going to look at 54 again and 9. So what do you multiply 54 by to get 9? So you can say 54 times your scale factor, which I'm going to call x, and you want that to equal 9. So divide both sides by 54. So that means that x would equal 9 divided by 54. You can leave that as a fraction, 9 over 54. And then when you reduce that, you divide both sides by 9, and you get 1/6. Okay, so in this case, the scale factor is 1/6 because 54 times 1/6 is 9. Okay, and notice how the scale factors for number 7 and 8, they are reciprocals of each other. Okay, so that's how you can check to make sure that you have the correct scale factor for those two triangles. Okay, number 9 says the height of a door in a drawing is a 1/2 inch. The actual height of the door is 80 inches. What is the scale factor from the drawing to the actual height of the door? Okay, so we're looking for the scale factor, so I'm going to let x equal the scale factor. So the scale factor is, what do I multiply the drawing length, which is 1/2, to get the actual height of the door, which is 80. So 1/2 times x times my scale factor of x has to equal 80. So to solve, you can multiply both sides by 2. So you're going to get that x will equal 160. Okay, so the scale factor is 60. Okay, so I'm writing sentences, but on the actual knowledge check, you would just have to write the answer. So you would just write 160. Okay, number 10. Adam made a scale drawing of the vegetable garden that he's planning, and it's shown below. He wants to put fencing around the garden using a scale of 1 inch equals 2.5 feet. Enter the perimeter in feet of the vegetable garden. Okay, so first I would convert the dimensions into feet using the scale that's given to us. So the fact that 1 inch is 2.5 feet. So I would write a word ratio since you're comparing inches to feet, and that's going to help me organize my work. So if my scale is 1 inch represents 2.5 feet, I write it as a fraction, and that's going to equal, okay, so now I'm going to take my length of 9 inches and figure out what that would be in feet. So if inches go in the numerator, I would write 9 inches in the numerator, and then in the denominator, I would write the actual feet. So I'm going to let x equal the feet. So I can write this without my units, so it's easier to solve. And now use your cross products. So multiply 1 times x and 9 times 2.5. So 1 times x is just x, and then 9 times 2.5, you can use a calculator to get that result. And you get 22.5 feet. Okay, so that means that my length would be 22.5 feet. So I'm going to label my drawing. Okay, so now I am going to calculate the width in feet. So again, I'm going to use my word ratio, putting inches in the numerator and feet in the denominator. So using the scale, that 1 inch represents 2.5 feet. And that's going to equal the inches, which is 6 inches. And then in the denominator, I'm going to calculate the feet. I'm going to call it feet y in this case. So now I'm going to remove the units and write 1 over 2.5 equals 6 over y. And then use cross multiplication or cross product. So multiply 1 times y would be y equals 6 times 2.5. So you can use a calculator to figure out 6 times 2.5 and you get 15. So it means that the width of this rectangular garden is 15 feet. Okay, and then to calculate the perimeter is the sum of all the sides. So add all the sides together. So you're going to have 22.5 feet. Remember, there's a top length and a bottom length of 22.5 feet. So that means when you write the perimeter, you can do 2 times 22.5 plus. For the width, remember there's 2 widths that have a length of 15 feet. So I'm going to label the left width 15 feet. So that means when I include it in my sum, I'm going to write 2 times 15. So I'm going to make those calculations. 2 times 22.5 is 45. And 2 times 15 is 30. So I get a final answer of 75 feet. Okay, so that's the final answer that I'm going to write in my answer if I were taking the test. So notice how there's a box here written for you, and it has the units right next to it. So that means in my answer, all I'm going to write down is 75. So in Illuminate, you would type in 75. Okay. So watch out, because this box here just means that's where you write your answer. So in Illuminate, you would have something similar, and you would just write 75 and the units are right next to it. So you don't have to type in the units. Otherwise, it could mark it wrong for you. In number 11, you have a triangle, and notice how on the grid, the width is 3 units and then the height is also 3 units. So it says a scale factor of 3 was applied to the figure. What would be the length of the new height and width of the triangle? So since both the length and the height are 3 units, then that means when we scale it by a scale factor of 3, then those are also going to be equivalent. So all we do is we take the side length of 3 and we multiply it by the scale factor, which is 3. And 3 times 3 would give us 9. So that would be the new length and the new height. So notice how there's a box here that says blank units, so you would write 9 units in that box. So on Illuminate, you would just type in 9 and then the units would be written for you already. Okay, number 12. The actual width of the building shown in the model below is 60 feet. So the width is 2 centimeters and the height would be 5 centimeters. They want us to figure out what the actual height of the building would be. Okay, so the actual width is 60 feet, and we want to know what the actual height is. So we can write a word ratio that compares the width to the height. Okay, so the width is 2 centimeters and the height is 5 centimeters equals, and then we want to set that equal to what the actual width and height would be in feet. So the actual width is 60 feet, so 60 would go in the numerator. And then in the denominator, we're trying to figure out what the actual height would be. I'm going to call that h. Okay, so I'm going to remove the units now that I've set up my proportion. 2 over 5 equals 60 over h. So cross multiply. So you're going to get 2h is equal to 5 times 60. So 2h would equal 300. Then divide both sides by 2. So the 2's cancel out. So h would equal 150. So if you look at your answer choices, you're looking for 150 feet. So that would be selection B. Okay, number 13 and 14, it says write and solve an equation of find x, then find the measure of the missing angle, round to the nearest hundredth where necessary. The pictures aren't drawn to scale. So in the first triangle, we have an angle that measures 38 degrees, an angle that measures 88 degrees, and an angle that measures x degrees. Recall that all the angles in a triangle add up to 180. So x plus 38 plus 88 has to equal 180 degrees. So then before you start solving for x, add your like terms. So add 38 and 88. You get 126. So x plus 126 is going to equal 180. So to solve for x, add negative 126 to both sides. So x is going to equal 180 plus negative 126. That would give us 54. So the value of x would just be 54 degrees. So the solution would be 54 degrees. And then classify the triangle by its angles. So because all the angles are less than 90 degrees, so they're all acute angles. So that means this would be an acute triangle. Okay. Number 14, find the measure of angle ABC. So angle ABC would be this angle here, the one that measures 3x minus 23. However, to solve for that angle, first we have to figure out the value of just x. So we do need to use all three of these angles to solve the triangle first. So 2x plus 3x minus 23 plus the 93-degree angle here. Angle C is 93 degrees. All three need to equal 180. So I'm going to rewrite subtraction as addition. So 2x plus 3x plus negative 23 plus 93 equals 180. And add your like terms. So 2x and 3x is 5x. Then negative 23 and positive 93 is going to equal 70. So 5x plus 70 equals 180. Then to solve, you want to add negative 70 to both sides. So you're going to get 5x equals 110. So now you can divide both sides by 5 or multiply both sides by 1/5. Dividing by 5 is the same thing as multiplying by 1/5. So x would equal 22. So we've just solved for x. It's asking us to find the measure of angle ABC. So ABC is the angle that I highlighted in red first, so that would be 3x minus 23. So what you want to do is replace x with 22 to solve for that angle. So 3 times 22 minus 23 is equal to 66 minus 23, which is 43 degrees. Okay, so I'm going to continue down here since I ran out of room. So the measure of angle ABC is 43 degrees. Now that's what the question is asking me to find. So if you're on Illuminate, you would just write in 43. But to classify the triangle, I do need to figure out the other angle measurement. So I do need to go back and figure out what angle A measures. So that would be 2 times x. So the measure of angle A is 2 times x, and we found that x was 22, so 2 times 22, that would be 44 degrees. So since we have an angle that measures 44 degrees, we have an angle that measures 93 degrees, and another angle that measures 43 degrees. Now, because angle C measures 93 degrees, that means that if the angle is greater than 90 degrees, then this would be an obtuse triangle. Okay, so this would be an obtuse triangle. Okay, so this concludes the review for 6.1 and 6.2. Make sure you study this review for your Module 6 knowledge check or quiz. A lot of these problems are very much like the ones on the actual knowledge check. Just because it's on Illuminate, you will either have some multiple choice questions or questions where you just have to type in the answer. You wouldn't need to write sentences, so just watch out for that so that you don't get penalized on the actual quiz.